And hello everybody, welcome back. Yeah, mic is working. Yes, okay, good. Hello everybody, welcome back. So you're on the next video of this radiation heat transfer learning journal. And in the last video, we're talking about some basic definition. What's a wave number? What is angular frequency? What is wavelength? Etc. etc. And of course, we are looking at Michael F. Morris's radiative heat transfer. You'll not be going through all of it, but it is a very useful reference. So, in the next segment, we want to ask the basic question of what a black body is. So, yeah, imagine, okay, so when radiation comes upon a surface, okay, let's not talk about black bodies first, let's talk about normal bodies, right? We talk about normal bodies, all right? So, yeah, I've been reading some of this in here. Yeah, but I'm not going to make you read through all of that, but yeah. I'm going to summarize what is in these paragraphs. Oops, sorry. What is in the paragraph 1.3. I'm going to summarize some of the content in the paint drawing I'm going to do. So let's say we have a regular body, right? And then we have some sort of radiation impinging on it. What can happen? Well, some of the light can be, or the radiation can be reflected away. All right, some fraction of it can be reflected away. Some fraction of it can be transmitted. So this is the reflected. This is transmitted. All right, transmitted. And then some part of it will get absorbed. I'll just write that in red. Absorbs. Okay, some of it will get absorbed, and when it's getting absorbed, it gets converted into heat. So this radiation, whatever wavelength it is getting converted into heat. And what does that mean? It means that it gets transferred to the vibrational motion of these molecules or atoms in this body. Okay, so what are some special cases of, this is a general case of a body with radiation impinging on it. So let's talk about some special cases. Okay. So let's say the absorption is low absorption or negligible. All right, so we have, again, just a recap, radiation, most of it, I guess, is transmitted. You have some reflected away. Okay, so low absorption, this can be called transparent. So it's all very negligible absorption. We call this transparent material. Let's talk about the next case. If you have low transmissions. Negligible transmission. So okay, so you have radiation coming in. Most of it either gets reflected or absorbed. So I'm just going to use the red thing to signify absorption. All right, so this is what we call opaque. Okay, now opaque can mean it's reflective. Okay, opaque can mean reflective. It's like a metal is reflective, like a mirror. Like you have steel, stainless steel. It is very reflective, but it is opaque because there's nothing being transmitted. Okay. What if we have low transmission? Let's give it low transmission and high and reflectivity. Okay, so if you have low transmission and reflectivity, we don't see any of the transmission going through. So it is opaque, yes, but it's a special class of opaque. All right. So what happens is that radiation, whether it's heat or anything, you're coming, and all of it will be absorbed. Now this is what we call a black body. So black bodies, they absorb anything that comes in. So I'm going to copy and paste some of these cases into this Word document. Okay, so the last case is how we kind of define a black body. All right, so we just quickly run through some of the cases. All right, and we often say that a black body is a good absorber, but good absorbers are good emitters. How do we prove that? Okay, so here's the rationale. I'll just run through very quickly so as not to waste too much time. Picture a black body, some randomly shaped black body in a medium, right? In a medium that's at some temperature, T1 or T0. Okay, so after a very long time, if the black body is cooler than the medium, then the black body in the center, it will rise its temperature. So the black body will absorb some radiation from this surrounding environment at temperature T0. Okay, it will absorb some radiation, and after that it will also emit radiation, right? So after some time, the black body will be at a temperature T0, right? The black body will be at some temperature T0. And what is the energy balance, right? What is the energy balance? Q times the area of the black body, some heat flux into the area of the black body, equals to Q absorb minus Q emit, and equals to 0. So at thermal equilibrium, Q absorb equals to Q emission. All right, makes sense, right? So then what's the result? What's the logical outcome of this? If we have at thermal equilibrium more absorption, then we find that at thermal equilibrium, the emission rate of the black body is also the highest. Because remember our special cases, right? I mean, when radiation comes upon a surface, we can have reflection, we can have absorption, we can have transmission, right? Black bodies, they absorb all the radiation that comes upon them. So then in thermal equilibrium, they also emit the same amount of radiation. So you can see that the best absorption is the best absorber is the best radiator. So let's just draw that out just for illustration purposes. Let's say you have this blue body, all right? This blue body in the middle that's not a perfect emitter. So we have radiation coming upon it. Okay, some of it will transmit through and refract. Okay, maybe there's some refractive index here. Okay, and some of it will reflect, and the absorption will be a fraction of what we have in the black body. So again, Q absorb. Okay, Q absorb equals to Q emit. So emission is not the same as reflection and refraction, right? So there's some transmitted radiation here, there's some reflected radiation here, and this is not part of the emissions of this body. Emission comes strictly from, okay, I have a hot surface, I have a surface at some temperature T1, and as a result of this temperature, I am emitting some radiation. So this is what it is. It is emission as a result of temperature, not as a result of the radiation bouncing around, being reflected or transmitted. So here we show that first property of a black body, it is the best emitter you can ever have. So this is how it is being proven fundamentally. Alright, so I'll stop here, and we'll see you guys in the next video where we'll talk about maybe more about black body spectrum. See you guys again. Bye bye.